So we've gone over the parent function of sine and cosine. We've gone over all of the vocab and what they're actually doing. So what I want you to do right now is turn, please, in your packet to page, as a spoiler alert, to page 18. And what I want you to do is look at these graphs and analyze them and kind of think what's happening here. So for example, A, it looks like a pretty standard sine wave, ends by 2 pi, as we can see. But you notice the amplitude is changing, okay? So the amplitude is 2. So our period's still 2 pi, but the amplitude is 2. So notice that. B doesn't really look like a sine wave to me. Our parent function, right? But it could have got shifted either back or forward pi, as you can see. And because of how the graph's drawn, I'm thinking it got moved back pi. Or, if you think about it, if you look at A and B, besides one being having a higher amplitude, they almost look like reflections of each other. Like if we could put a mirror on the x-axis, they're just reflected. So I'm thinking this either had a phase shift, right? It got moved back pi, or, like I said, a reflection. Okay, this one, as you can see, we're finishing our cycle a lot faster. It finished before 2 pi, so in half the time. Okay, and then this one, usually it goes, as we can see, we're used to it going through the x-axis, but this got shifted up 1. But other than that, everything else looks normal. Okay, so I suggest you pause this video, think about that, and then answer number 2. Okay, so hopefully you paused, and take a look here. So 2 is C. So you can see this is where the B normally is, the little b. So we're affecting the period. So it took 2 pi and it divided by 2. And so the period, meaning a cycle, ended by pi. Okay? Now A just affected the amplitude. That's it. So the amplitude went up to 2. B was, yep, a phase shift. So not a reflection like I said, but a phase shift. So if you take x minus pi, set it equal to 0, add pi to both sides, that got shifted positive pi. So I drew it wrong. How it actually wanted it to be is shifted, shifted over to pi, right? And then D, the midline just got moved up 2. So pretty sweet. Okay, but 3 talks about what I was talking about. We can shift forward pi, and it'll be the exact same as a reflection. So if you think about it, sine takes the inputs, gives you an output, and then we just make it negative. So if you remember, a normal sine wave is 0, 1, 0, negative 1. So it just flips those, right? Reflects them, the negative. So you plug in sine 0, you get 0. Negative 0 is still 0. Sine of pi halves. Here's sine of pi halves. Normally we should get 1 when we do sine of pi halves. But now there's a negative in front of your sine, so we get negative 1 instead. And then the same thing happens with negative 1 at 3 pi halves. Negative 1 made negative becomes positive. All right, slick. And you can take a look at these. I'm not going to in this video. Your teacher probably did in class, so if you have any questions on those, just let me know. Okay, we went over this in the previous video, splitting it up so it's not so much at once. All right, so this is going to affect our amplitude, if you remember where it's located. So cosine will take its input, give its output, and then we're multiplying it by negative 3. So it's going to make our amplitude go up 3. So normal cosine, if you remember, is 1, because it's the x value, 0. Oops. Negative 1 and 0 normally. So cosine at 0, right? So when we're at 0 radians, the output is 1, but we're multiplying it by -3. Okay, so it takes us down to -3. So it reflects it and gives us an amplitude of 3. At pi halves, we're at 0. And then at pi, we're at -1, but -1 times -3 will take us up to 3. And then cosine of 3 pi halves gives us 0, but 0 times -3 is 0. And then cosine of 2 pi is 1, but 1 times -3 is -1. So there's my one cycle of my graph, one period of the graph. So if you notice, the period didn't change. We still ended in 2 pi because b is 1, right? There's nothing in front of that x except for a 1. There is no phase shift. The midline is still the x-axis. That's still the middle of the graph. So the only thing that was affected was the amplitude. And because the amplitude was negative, it reflected it. All right, let's look at B. So we're going to graph this thing. So before you get excited about graphing it, E was really nice. We could just think of it as cosine x and then multiply by -3. We've got to do stuff with our inputs first. So you notice we're still going to start and stop at 2 pi. Nothing's affecting our period. But there is a phase shift, so it might not actually start on 0 and 2 pi. It'll still be that long, but probably not going to actually start there. So we're going to set this equal to 0, because that's what we talked about earlier. We're going to add pi halves. So x equals pi halves. So this is a positive phase shift. So positive means we're going to move to the right. So we're going to start our graph here at pi halves. So instead of plugging in 0 radians, 0 minus pi halves, our input will become, right? So if we plug in 0 radians or pi half radians, they're all going to be affected by this negative pi halves. And this is an easy way to do it. You set it equal to 0, and that'll be your new beginning. Okay? All right, so our midline is not affected at all. There's no D over here, right? No D over here where I'm circling. So we only have amplitude, phase shift, nothing's happening to our period. So our amplitude is going to go to 2 and down to -2. Okay, and then we can just take our sine parent function, which is 0, 1, 0, -1, 0. So pi halves, and then we have to end 2 pi away from pi halves, right? Because we still have to finish our period in 2 pi. So notice pi halves is 2 blocks, and we're going to run out of room. So it's going to end over here at 2.5 pi. This is where it will end. All right, so I'm going to now do our job. Okay, so at pi halves it'll be at 0. At 2.5 pi it'll be 0. Now I'm just going to find the middle. 1, 2, 3, 4, 5, 6. All right, so just find the middle there. So at 3 pi halves will also be at 0. So at pi will be at 1, and at 2 pi will be at -1. Boom, boom, boom. So what the heck just happened there is I remembered, take a look at this blue graph, right? I remembered the 5 points, 0, 1, 0, -1, and 0. I phase shifted it to pi halves. Oh, shoot, I made a mistake, right? I forgot about my amplitude. I was so caught up in the phase shift. So let's phase shift this sucker. Okay, so phase shift, move me right pi halves. Amplitude should have gone up to 2, but 0 multiplied by 2 won't change anything, right? And down to -2. So we have a higher amplitude, and there we go. Okay, so we had our phase shift. Our midline didn't change at all, and our points went up to 2 instead of 1 because of this multiplying by our output. All right, think about that. Okay, number 2. So we know that we're going to have an amplitude of 5, and our midline is going to be moved up 2. So our new midline will be at 2. This will be our midline. Our amplitude is going to go up 5 from that. 1, 2, 3, 4. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So this will be the top, this will be the bottom, the max and the min, because it had an amplitude of 5 and a midline change up to 2. And our period is going to be sped up. There, we can tell there's no phase shift, but our period will be sped up. So our period is found by taking 2 pi and dividing it by b. So dividing it by 1/2, which is 2 pi times 2, because instead of dividing by a fraction, we can multiply by a reciprocal. So this will end at 4 pi, which I'm really going to have to extend. So I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So my graph will start at 0 because there's no phase shift, but end at 4 pi because this 1/2 is affecting the input. It's halving the input every time I plug it in, so it'll move a lot slower. Okay, so my midline here. I'm dealing with cosine. Remember, cosine doesn't start at the midline. Cosine starts at the max. So I'm going to put a dot up here. There's my cosine. Okay. So normally my next point is at pi halves. So 0, pi halves, pi, when I'm doing a normal cycle of cosine. But remember, this is going half the speed. It's going to be a really drawn out cycle. So what I'm going to do is I know that the end of cosine, it'll start where it ends. That's a cycle, okay? I know at 4 pi I'll be there, so I'm going to find the middle and put it down here at negative 5, right? I mean negative 3. So our amplitude was 5, but that puts me down at negative 3. Okay, then I'm going to put our midline. Normally cosine is at 0, but our midline got shifted up. So that 0 point of the cosine is on the midline. Then I'm going to find halfway here also, and then that'll be there as well. So here's my cosine wave, but it's really slowed down. Takes half the time normally to finish a period. I mean, it takes double the time because we're halving our input. So we won't finish till we get to 4 pi. 0 to 4 pi is our period. Okay, so our period we found was 4 pi. Our amplitude was 5. And because we switched the midline, that affected our range. So with a midline at 2 and an amplitude of 5, that took us to 7, but down to negative 3. And our domain is negative infinity to infinity. Now, if you watched the video earlier, I talked about this one a little bit. So our A is our amplitude. So if we go to the midline and count up, we know that our A is just 1/2. B is our period. So we can see the cycle from 0 to finishing the cycle, 0, 1, 0, negative 1, 0. We got from the beginning of the cycle to the end of the cycle is 2 pi, which is normal. So our B will be 1. Now I could do that algebraically, right? So we know 2 pi over B equals our period. And because our period is 2 pi, if we multiply both sides by B, we'll get 2 pi equals 2 pi b, and if we divide by 2 pi, we'll get 1. So our b is 1. Now our c, the midline, got dropped down to negative 1, so our c would be negative 1 in this case. Okay, so let's talk about 4. Which of the following equations is not equivalent to the other three? So cosine of x plus pi halves. So if you think about it, this is a phase shift. So it's moving it back pi halves. So normally cosine goes 1, 0, negative 1, right? But it's going to go back because you have to set it equal to 0. So we have a phase shift of negative pi halves. So cosine will start here at negative pi halves, boom, and be at 1, and then at 0, and then at pi halves, it'll be at negative 1, and then at pi, it'll be at 0, and then at 3 pi halves, it'll be at 1. Okay, so that's what A will look like. Let's do B is going to be negative sign. So normally starts at 0, but if you make 0 negative, it's 0. At pi halves, it's normally at 1, but if you make 1 negative, it'll go there. And then 0 is at pi, but 0 made negative is 0. So we can see that A and B are going to be the same thing from those points, right? Now let's do C. So if we take x plus pi, set it equal to 0. If we minus pi, we'll get x equals negative pi. So it's going to take our sine wave and move it back to negative pi. So sine starts at 0, then goes to 1, then 0, then negative 1. So we can see that that's going to be the same graph as well. Okay, so negative cosine is going to take normal cosine, which starts at 1. So remember, normal cosine, the graph is this red guy up here. So it'll be 1, 0, negative 1. But we're flipping it, we're making it negative. So it'll be negative 1, 0, which we can see negative 1, 0, positive 1. So we can see that that's not quite the same thing, right? So D is not the same as the others. Just reviewing that. Okay, so let's do another one from your homework. Let's do, let's see. So let's do 8. So turn in your homework, find 8. Do one here. Sorry, something on the screen. Okay. So you sit down to your homework. You got to remember this affects the amplitude. There's no C, so there's no phase shift, but our period will be changed, and there's a midline change. So our midline is now going to be at 1. I'm going to put an M to remind myself my midline's at 1. So I took care of that. Now my amplitude is, let's put that vertical shift up 1. I forgot that was over there. Okay. All right, so we took care of that, thinking about that vertical shift. We took care of our amplitude. There's no phase shift because there's no C, but our period is going to be affected. It'll be 2 pi over 3. So this is going to finish at 2 pi thirds instead of 2 pi. So 1/3 of the normal, okay? So it's speeding up, it's finishing in 1/3 of the time because we're multiplying by 3, we're speeding up the inputs. All right. So let's say that this is, so 2 pi thirds, 2/3, right? So let's just kind of break this up. So let's start at 0, and let's say, let's just do this. So this will be 1/3 pi, and then 2/3 pi. So as you can see, we left the axes blank, so you could kind of space it out however you wanted, okay? So just, our period needs to end by 2/3 pi, so there you go. Okay, all right, so our midline will be at 1. Our amplitude is going to go 2 above that and 2 below that. There was no phase shift, so that's good. So we're going to start on our midline, but up at 3. because our midline got shifted up 1 and then the amplitude is double. So cosine will start here at 3. Then I have to fit in 5 dots. So 1, 2, 3, 4, 5. So I just use those 5 points that I talked about earlier. So 1, 2, 3, back up to the midline, 4, and all the way up. Okay, so I took care of my amplitude, took care of my midline, and I sped it up. It's finishing way faster than 2 pi. So here is my graph. Now, domain and range. This is actually going to go left and right forever. So negative infinity to infinity. I stopped drawing it because I did a cycle, but it could go on left and right forever. Range is -1 up to 3. -1 up to 3. Okay, so let's look at something with a phase shift. So let's look at 10. Okay, so 10 is going to have a phase shift. So I'm going to take this, set it equal to 0, add pi halves to both sides. So my phase shift will be right pi halves. So I'm going to label this as pi halves, pi, 3 pi halves, 2 pi, and then 2 pi plus a half will be, let's think of that. Look at the unit circle if you want to. So 2 pi plus a half, do that. Okay, I'm going to leave it like that for right now, but think about that. Okay, right pi halves. Now the amplitude is going to be 3, there's no vertical shift, and the period will end in 2 pi. Alright, so let's draw that out. Sorry. Okay, so we're going to start our cycle, our normal sine wave cycle, at pi halves because of the phase shift. So it'll be here 0 at pi halves. Notice I'm going to go up 3 from the midline. That's the amplitude, distance from the midline to the max. And then I'll also go down 3. So here we have pi halves. Then I'm going to go up to complete the amplitude, and then 0, and then down, and then here at 5 pi halves, we will have our full cycle. Now, period didn't change. It still takes us 2 pi to finish a graph. So if you think 5 halves, which is 2.5, right, minus a half is 2 pi. So 2.5 minus a half is 2 pi. So I still finished my period in 2 pi. I just had this phase shift pull me over. And my amplitude was 3. All right, so there's your homework. Give that a shot. If you have any questions, let me know.